right, more operating procedures. When we talk to satellites, kind of like talking to a repeater, only a little bit different. If you're a technician class license or higher, you can operate on the VHF and UHF bands. Satellites will have an uplink downlink mode, which is specified for the particular satellite, and it'll be either listed as a U/V or V/U. What that means is if it's a UV, it means that it's receiving on UHF like 70 centimeters, and it's transmitting on 2 meters. If it's a VU, it's just the opposite. It means it's receiving on 2 meters, it's transmitting on 70 centimeters. So it's like a repeater where you got the offset. In this case, the offset is the VHF UHF band. The modes that are typically supported are single sideband FM, CW or Morse code, and data.
Yeah, digital modes, I guess.
Yeah. Which amateurs, things like Whisper and APRS and stuff like that.
Yeah, I mean, anything digital.
Which amateurs may contact the International Space Station on VHF bands?
Delta, since we're doing it.
Bravo.
Sticking with Delta.
Well, that's not what NASA's saying right now.
Oh no, anybody can.
Yeah.
NASA's saying you can't contact them without applying first. You need to let SEC know. Who overrides who? NASA's not in charge of the air.
We're talking about the amateur band, and we have astronauts who are amateur radio operators, and people talk to them every day. Doesn't require permission from NASA.
Yeah,
on the amateur
they
band.
can ignore it.
Yeah, it is. The ARISS program is administered by NASA.
But they can ignore
Right.
it. They can't make a rule. The FCC owns the air.
Yeah. They just won't talk to you.
Right. They can make it. They can say, "Hey, I'm not listening to you. You didn't follow my rule
Okay.
to
That's
knock
good.
on my door. You just walked in my house. That's fine." But they don't own the air. The FCC does.
Okay. What is meant by the station that a satellite is operating in UV mode?
Bravo.
Anybody out there in Zoom land?
Bravo.
We didn't mention 15 meter at all. And it's not ultraviolet.
Yeah.
Get a suntan from the satellite.
What mode of transmission is commonly used by amateur radio satellites? This is not just space station.
all of them.
Delta, all of them.
All of the above.
Okay. Satellites, because they're solar powered with batteries, have some power limitations, and they have an automatic gain control function to kind of manage the power. So if you send a very strong signal, it causes blocking of weaker signals through that transponder on the satellite because it has to manage the amount of power. So if it's got to send more power for a strong signal, then it kind of blocks the weaker signals.
Who owns the satellites which the amateur radio operators can communicate with? Are these FCC owned? Are they military, government? Is it anybody's? Who can you talk to?
Amateur radio operators, clubs usually. CubeSats are becoming more popular where colleges and high schools are building CubeSats, and if they're lucky, they might get them launched where the CubeSat is a specific size, and they have these kind of launcher tubes where they load a bunch of them in, and then they just, when they get up in orbit, they'll shoot them out.
That's gotta cost some money though. That's not free.
Yeah, well, it depends. You know, if you're lucky and you can get it launched, maybe, you know, if they got space, you might get it launched for free. If you had to pay for it, yeah, it's expensive. Building a CubeSat is not cheap. We had a couple presentations here recently at a couple of the clubs on it, and you can probably do the simulator for a few $100s. Actual CubeSat needs to be a little more rugged, and probably in the thousands to do it. But they're amateur operated
That's
satellites.
pretty cool though to have one up there.
Yeah, and you can track it. They'll usually send out APRS data. May have beacons on it. They usually put some measurements where it can measure temperature and pressures and ultraviolet and muon detectors and all kinds of stuff like that. Send that data down.
A lot fancier than the first Echo balloon.
Most satellites will have a beacon where it's a downlink broadcasting information about the satellite, temperature, current, voltage, things like that. One of the things, and I can't say I've ever done it, I haven't talked to a satellite yet. One way to verify that your uplink power is not higher than necessary is the downlink signal that you're getting should be the same as the beacon that you're receiving. So if you get a signal indication on your downlink and you compare it to what is being received from the beacon, if they're the same, it means you're set up properly. If you're much higher, then you're probably operating with a lot more power than you really need to, and you could be blocking other signals because of that. At least that's my understanding. Never having done it, I don't know for sure. What is the impact of using excessive radiated power on a satellite uplink? Which of the following is a way to determine whether your satellite uplink power is neither too low nor too high?
Charlie.
Yeah. I think, and the implication on this stuff is that when you transmit on uplink, okay, it's just like a repeater. The downlink is retransmitted with yours at the same power level as receiving, which is why you could be blocking other signals. And that's where you can check it compared to the beacon, which is always going to be a constant power level. Leo, These are low Earth orbit satellites that are in the 99 to 1200 mile orbit. It takes anywhere from 88 minutes to 127 minutes to circumnavigate the globe.
You have a very short window of time to talk to them because they're only visible for minutes.
Yep. But they do have a high bandwidth, so you can get a lot of data in that short period of time. You can see the satellite.
Space station from here is 35 to 45 minutes that you've got access to.
They're traveling at like 17,000 miles an hour.
Mhm.
Well, we're traveling at 1,000 sitting here.
Right. Spinning at 1,000. We're traveling, the Earth is traveling about 67,000 miles an hour.
So what is a LEO satellite?
Delta.
Don't be confused with a low energy operation mode. I'm not sure what that is. Okay, beacons.
One that operates for law enforcement officers.
Basically sending out telemetry. Most satellites have them. Even things like CubeSat, the amateur built ones. There are a number of software packages where you can track these satellites. There's one I found here recently called Simon's World Map, and it gives you a whole map of the Earth, and you can have it. You can pick which satellite orbits you want it to show, and we'll track them. It also will show things like the auroras, where they are. Lately, some of the auroras have been down into the upper United States, below Canada.
There's a movie a long time
What's
ago.
that called again? Simon's World Map?
Simon's World Map. Runs on Windows. I don't know if there's a Mac version or not. There might be an Android version. I don't.
Simons. There's a movie called Frequency
Yeah,
from like the 2000, something like that.
Yeah.
Have you ever seen it?
yeah,
Dennis Quaid. Good movie.
yeah.
I mean, they use the Borealis to
Oh,
send a signal to another dimension.
well, I don't know about that, but you can bounce signals off of it.
I know it's not real, but it's still
Well, it could be. Who knows?
it's still a cool movie that they did.
Okay, so the beacons transmit health and status information of the satellite normally. Things like voltage, current, temperature. And in the case, if they're a non-military satellite, then anybody can receive it. All you have to do is find out what frequency it is and what the orbit is, so you know when it's passing over close enough. If it's military, it's probably encrypted and you're probably not going to be able to listen to it. This is a little chart showing a lot of the satellites and what they have on board and the frequencies. You can find these things on the internet that list them. Like in this case, this first one, it's got digital telemetry on that frequency, a CW beacon, which means the information is being sent Morse code, and a linear transponder, which is just like your kind of repeater in space sort of thing. What is
Can you just go back in for a second? I'm sorry. Its channel bandwidths are like way off, like that 30.1, 20.
well, the beacon, which is CW, is very low bandwidth. Okay, it's 100 hertz.
Right.
So you only need 50.
The other ones that
30 kilohertz is wide enough for wideband FM even.
I've only had the handhelds and they don't go up that high. So I guess this must be special equipment.
I don't know. But, you know, the bandwidth is enough to handle most communications. So what is a satellite beacon?
Delta.
Delta. I like the indicator light, shows where to point your antenna. Would be
That'd
nice,
be handy.
assuming you can see it. What telemetry information is typically transmitted by satellite beacons?
Delta.
Oh, yeah, I guess. I was gonna say health status, but I'll go whatever everyone else.
Well, it's definitely Charlie. Could also be Alpha. Could be Beta or Baker or Bravo.
NTP. That's
Let's
it.
see.
Okay.
Hmm.
Yeah, because
So
that.
You
I'm
think
guessing
that-
it
I think
doesn't
the trick
transmit
here
the
is
time
says
of day because it's all over. I mean, there is no time of day unless they're using a standard for something.
Well, you
Yeah.
didn't mention that. though.
no, and you know that would be implying like it was GPS or something.
NTP time.
And the question says typically transmitted. I mean, you might have a satellite that does all of these, but it's not typical. Typically, all you're going to get is health and status.
The GPS satellites do all that. And that's where we get our NTP clocks.
Who may receive telemetry from a space station? And remember, it's not the space station, it's a space station, which is anything 50 kilometers and up.
Anyone,
Alpha.
anyone with a scanner.
With a radio or receiver.
Yeah,
B.
scanner.
Oh,
It is a
B.
scanner.
Oh, anyone.
Scanners
not
can
the
be by
transmitter, just
anyone, so
receiver.
that means anyone.
With a
Right.
crystal set if you know how to tune it right.
Right. Okay, so satellite tracking, there's a lot of programs that you can find. Some are you have to buy, some are free. Simon's World Map is a free one. It kind of simulates there's one called Geochron, which is really great, especially for large screen TV. Of course, it costs $450. And the Simon World Map does a very, very similar thing, just not quite as detailed. And these programs will usually give you a map, like a world map, and show position information or real-time tracking, usually because these stations are sending out like APRS data, which includes their GPS coordinates, so you can track where they are. The satellite information, I think, is basically done from the calculations from what they call the Keplerian elements, and their ARL, for instance, sends out at least once a day, might even be more, a message containing the Keplerian elements, which is all the orbital information for all these different satellites that these programs can use to calculate where they are.
I thought those are elements that came from the planet Capliria.
I think he was an astronomer. Kepler is where it came from.
Kidding. It just
Um,
sounds cool.
Some of them will show Doppler shift, which if you're trying to talk to a satellite, one of the things you have to take into account is you have to change the frequency because of Doppler shift. So as it's coming towards you, the frequency is going up, and as it passes over and goes away, the frequency goes down. So you've got to be able to manually tune it or have a program do it for you. And some of these programs will actually control antenna elevation and azimuth to track the satellite
position.
and adjust the frequency on your receiver. But there are people that go with a handheld little Yagi and a walkie-talkie and do it.
Really?
Yeah. They're like satellite whisperers.
Yeah.
Here's I don't know which one this is, one of those programs. Orbitron. And it gives you stuff. You can pick over here the different satellites for it to track. It's got real time, UTC data, clock time. I think that's just a symbol. I'm not sure what that one is. It gives you information about whichever satellite you have selected. The stuff like eccentricity and perigee and all those things are part of the Keplerian data. That's how it calculates the orbit and that stuff.
They all go in the same direction?
You know, I always thought they did, but in looking at some of these, it seems like particularly the CubeSats seem to be going in the opposite direction. I don't know. Which of the following are provided by satellite tracking programs?
Delta.
Delta.
I think that's correct. Which of the following are inputs to a satellite tracking program?
Beta. Bravo. Sorry.
It's okay. I always wanted to call it Baker.
Mm.
I learned Baker when I was growing up, so I keep forgetting it's Bravo. Okay, we talked about some of the problems of trying to actually communicate with a satellite is taking Doppler shift into account because the apparent frequency is going to change. It's going to increase as it's coming towards you and decrease as it's going away from you. If you remember, if you ever watched Big Bang when Sheldon's wore his Doppler shift suit. There's also spin fading.
No, I'll have to find that episode.
Where the satellites in most cases are rotating, which means their antenna is rotating, which means it's not either vertically or horizontally polarized. Okay. At any point in time, it's one, but it's rotating. So you get a rotating polarization. But one of the things that people do is they have cross-polarized antennas. It's basically like two Yagis at 90 degrees. So they can receive either polarization, and as it goes around, okay, it goes from one antenna to the other antenna.
There's a documentary just a couple of years ago that I watched. And this guy has this thing took up practically his entire lawn antenna. And
Yeah.
it didn't make any sense at all to me. Like the amount of antennas that was connected to this thing, and he was able to, like position it and all this cool stuff. Look it up if you haven't seen it. It was pretty cool stuff.
Well, you need something like that for moon bounce. What is Doppler shift in reference to satellite communications?
Charlie.
Charlie.
What causes spin fading of satellite signals?
Bravo.
Charlie.
Bravo.
Bravo.
Yeah.
And the reason they call it spin fading is if you just have a, say, a vertical or a horizontal polarized antenna, as the satellite rotates, the signal is going to go from maximum to minimum and back again. So you'll see it fade in and out as the satellite rotates. That's why they have the cross antennas, so they can pick it up both ways.
I'm thinking a dish would fix that problem with having, you know.
Yeah, most
dish.
people don't have a dish.
I mean, okay. I have a dish that repurpose my old
Yeah, they're
Circular.
good.
TV
A
dish.
circular
Use it now.
polarized, Yagi is what really works.
Okay, so we learned that any technician or higher can access the International Space Station, that they have a mode for uplink and downlink, and U is for UHF and V is for VHF, which specifies which one is which. They normally support single sideband FM, CW, or data. If you're using excess power to the satellite, you can block other users because of its power management on board the satellite. And one way to check that you're using correct power is to monitor your signal strength compared to what the beacon is putting out. LEO stands for low Earth orbit satellite. Most satellites have beacons and they transmit status information. Anybody can receive it unless it's a military satellite. Satellite tracking programs usually show a map with real-time tracking of the satellite. Things like time, azimuth, elevation, apogee, perigee, all that kind of stuff. It's calculated from the Keplerian elements that you have to input to the program. And there's various sources of them. The ARRL puts them out. I think other people do. I somehow got signed up for the ARRL one, and I get one of those emails like every day. Doppler shift is a problem you have to take into account. So you've got to be able to either manually or have one of these tracking programs control the VFO on your receiver to compensate for the frequency shift. And spin fading, if you don't have a cross-polarized or circularly polarized antenna, you're going to have fading of the signal in and out as the satellite rotates.
So, like a little, I don't want to spend too much time, but how does the frequency change? Because the distance or, you know, there's some changes from the.
Well, all right, what is,
Like,
okay,
I'm transmitting at a frequency.
a particular frequency has a particular wavelength, right?
Mhm.
Which is how far the signal travels in one cycle. Okay, we usually measure it in meters, 300 million meters per second. Well, as the satellite is moving towards you, the effective wavelength shortens.
Oh, so it's in the, it's.
If a shorter wavelength is a higher frequency. As it's going away from you, okay, it tends to, it lengthens.
So it's during the time of that motion, not when it's in place. So if it's further away.
If, yeah, directly overhead,
As long as
everything's fine.
Yeah.
If it's infinitely far away, everything's fine. But as it approaches you or goes away from you,
It's changing.
right? You know, the old,
That makes sense.
you stand at the railroad crossing and the train's coming. And if you listen, you'll hear the change in pitch as it comes and goes. It's not a big one because the train's not moving that fast. Satellite's moving pretty fast.
But if you're far enough away from the train, the shift is less.
Gotcha. Yeah, if you're like 3 feet from the track, it's moving at 100 miles an hour or whatever.
And you're not paying attention to the sound, you're trying to get out of the way.